Today we're going to talk about angles and radian measures. So the first thing we have to talk about is a few key vocabulary. So the first key vocabulary, and I'm going to see if I can type this versus write it, but let's first change this font size. Perfect. All right, an angle, if you'll let me type maybe. There we go. An angle is two rays with a common endpoint. So the definition of an angle is where I have two rays with a common endpoint. So if I were to take, here's a ray, they have that common endpoint. That's what would get an angle, okay? So, and how we get the initial side of an angle. So when I'm talking about this in relation to our trig unit, the initial side is the side that remains stationary. And it's always the positive part of the x-axis. So if I have a coordinate plane, the initial side is always the positive part of the x-axis. That right there is 1/2 of my angle, and that's the initial side. Okay. So now, if we talk about the terminal side is the side of the angle that moves. It's the side of the angle that moves. So when I take my angle, so right now my two rays are stacked on top of each other, and when I move it up, that's going to get me that ray, and that's going to be my terminal side. So my initial side stays the same, stays stationary. My terminal side remains the same. So if we talk about standard position, this is what the standard position of your angles always make. So the standard position is when the vertex is at the origin and the initial side is on the positive part of the x-axis. So just like I mentioned it. So we're only really going to be focusing on the standard position. Okay? We have two more vocabulary words we have to talk about, counterclockwise and clockwise. If we talk about counterclockwise, counterclockwise means I'm making a positive angle. And if I go clockwise, I'm making a negative angle. So if I type this again, so we have it negative. So if I were to go in this direction, that's counterclockwise, my angles are becoming positive. If I were to go in the reverse direction, if I were to go down, then that would make a negative angle. So positive angles always go up, negative angles always go down. You can also think about it like that. Okay? So if we think about a coordinate plane, I draw another coordinate plane down here. Okay? This is 0 degrees. In order for me to go full circle, that would make 360 degrees. So what would make me go half circle? Well, that'd be 180 degrees. Well, what's half between 0 and 180? Well, that would be 90 degrees. So the positive y-axis is 90 degrees. And if I were to go between 180 and 360, halfway is there is 270. So now, if I go halfway between 0 and 90, that's 45. Halfway between 90 and 180, that is 135. Halfway between 180 and 270 is 225. And halfway between 270 and 360 is 315. So that's just numbers you can memorize. If you want me to be honest, you definitely want to memorize the 4 axes right there. So let's go ahead and let's start looking. It says draw an answer measuring 120 degrees and 210 degrees. So I know 180 degrees is here, and I know 0 degrees is here, and I know 90 degrees is up there. So if I wanted to get to 120 degrees, so my initial side stays here, so one of my rays stays there, and to get to 120, I got to go to 90 and then past it. That's going to be 120 degrees. That's what my angle would look like. If I want to do negative 210, I don't want to go up first, I want to go down first. So I'm just thinking about it backwards. So this would be negative 90, and this would be negative 180, and this would be negative 270. If I want to do negative 210, I'm going to go down past 180 and a little bit past it, but before 270. and that would be that angle. So if you notice 210 and 120, negative 210 and 120 degrees, they look like they're kind of in the same spot, but they're actually not. And the 120 is talking about this angle, and negative 210 is talking about that angle right there. So if we go ahead and we talk about make 215 degrees, since it's positive, I'm going up. So it's going to go past 180, but before 270. And that would be my angle right there. 400 degrees. So I start with my initial side. So I know this is 360, but I got to go a little past 360 to get to 400. So it's going to be there. So go ahead and pause this video and you try the last two on your own. So 720, that's just 2 times in a full circle. So that's right here. Negative 100 degrees, here's my initial side, and I'm going to go down past negative 90. And that's what that would be. So now, if we go ahead and we talk about what it means to be coterminal. Coterminal angles. What it means to be a coterminal angle, it is the angle with the same terminal side. And how I get the same terminal side is I just add or subtract 360. If I had 60 degrees, so if I have this angle right here, 60 degrees, okay, and I have this point, if I wanted to get this exact same point, I would either add 360 or I would subtract 360 and I would get the exact same point. And that's what it means to be coterminal. So if I want to look at this example, negative 400, so I'm going to go all the way around and then a little bit extra. That's right there. So now if I do negative 400 plus 360, that equals negative 40. So that would be a coterminal angle. And sure enough, if I were to graph negative 40 on another coordinate plane, notice this and this would look the exact same. I could also do negative 400 plus 360 plus 360. So that's negative 40 plus 360. So that's 320. So if I were to graph 320 degrees, that's just before 360, which sure enough, notice this matches this, which matches that. That's what a coterminal angle means. Okay, so it's any number I can either add or subtract. I could also subtract 360. Negative 400 minus 360 is negative 760. That is also coterminal. Okay? So if we go ahead and we now talk about what it means to be a radian. Radian is another way to measure angles. Radian is another way to measure angles. A radian is an angle whose arc length equals the radius of a circle. So what that means is if I had a circle and I wanted to find the arc length, let's say between this arc length right here, this radian is an arc whose arc length is equal to the radius. So whatever this arc length is, it equals that radius. So if that radius was 4, arc length would be 4. That's what it means to be a radian. So if we take a look when we talk about it, it says the circumference of a circle is 2 pi r, right? Circumference of a circle is 2 pi r. So that means there are 2 pi radians in a whole circle. So 2 pi is equivalent to 360 degrees. So if I go and I look at this picture, and again, I have 0, and if I were to go all the way around it, that'd be 360 degrees, which is equivalent to 2 pi. Because the circumference of a circle is 2 pi times the radius. So it goes 2 pi times around that circle. Okay? So if that's 2 pi, over here it would be half of 2 pi. Well, that would be pi, which means pi is equivalent to 180. All right, well, and what's the difference with half of 0 and pi? Well, that's pi over 2. So 90 degrees is equivalent to pi over 2. And then from pi to 2 pi, well, that's 1.5 pi. So if I turn that into a fraction, that's just 3 pi over 2. So when I want to convert these and I want to be able to draw angles with the following measures in radians, you want to think about it, okay, is it more than pi? So here I have 1 pi, here I have 2 pi. Here I have 1.5 pi, and here I have half a pi. So I just think about it in terms of that. So pi over 2, well, that's half of pi, so there's my initial side. So half of pi is just, oops, if I can draw straight, right down the middle. 2 pi over 3. Well, 2/3 is less than a pi, but 2/3 is greater than a half. So I know it's greater than a half, but not quite a whole pi, so it would be right there. 7 pi over 6, well, 6 goes into 7 about 1 time, so it's 1 and some change. So I'm going to go to 1 pi and then some change. And that would be my answer there. Negative pi over 4, well, that's less than half of a pi. So since it's negative, I go down, and that would be right there. And so now let's go ahead and let's talk about what it means to be coterminal. Coterminal angles, remember, I'm just adding or subtracting 360 degrees. But when I put it in terms of pi, I'm adding and subtracting 2 pi because 2 pi is equivalent to 360. So here it says find 2 coterminal angles, one positive and one negative. So I'm going to do 15 pi over 9 plus 2 pi and 15 pi over 9 minus 2 pi. So I'm going to convert 2 pi into common denominator. So I'm going to do, it's going to be 18 pi over 9. Oops, I can't write today. So 15 plus 18 is 33 pi over 9. And then if I do, turn that again, common denominator is 15 minus 18, that's negative 3 pi over 9, which is equivalent to negative pi over 3. So that's 2 coterminal angles. So if I were to sketch 33 pi over 9, and I were to sketch negative pi over 3, I would get them in the exact same position. They would make the same angle. So 4 pi over 3, if I want to find a coterminal angle, 4 pi over 3 plus 2 pi, 4 pi over 3 minus 2 pi. So, okay, I have a denominator of 3, so I'm going to multiply the top by 3, so it's going to be 6 pi over 3 and 6 pi over 3. So, 4 plus 6, so that's 10 pi over 3, that's 1 positive. And here I have negative 2 pi over 3. Okay, so I want you to go ahead and I want you to find one positive and one negative coterminal angle for the rest of these problems. And then you can check your answer on the answer key. Now, let's go ahead and talk about converting from radians to degrees and from degrees to radians. So I want to be able to use radians and degrees simultaneously. I want to be able to use one sometimes and one the other time. So I want to be able to know how to convert. So when I'm going from degrees to radians, I want to multiply it by pi over 180. And if I'm going for radians to degrees, I'm just going to multiply by 180 over pi. Okay? And that's just something you have to memorize. So whenever you see pi, that means it's in radians. Okay? Whenever it's not in pi, that means it's in degrees. And remember, 2 pi is equivalent to 360 degrees. So if I look at this first example, I want to convert 135 into terms of radians. So I'm going to do 135 times pi over 180. So this is where I would definitely cross reduce. So I'm going to ask myself, okay, 135 and 180. I know 5 goes into both. So that's going to convert to 27. 180 divided by 5, that's going to convert to 36. So now I notice 3 can go into both of these. You're not going to be able to figure out this much faster than I am. So 9 goes there, and 12 goes there. Oh, actually, that was a really silly thing to do because yes, 3 goes into it, but 9 also goes into it, 3 and 4. So now I'm left with 3 pi over 4. If I want to convert negative 80, I'm going to do negative 80 times pi over 180. So I know the zeros are going to cancel out, and then 2 goes into both, so negative 4 over 9, so that's negative 4 pi over 9. So negative 80 degrees and negative 4 pi over 9 are equivalent. So you're going to do the last two on your own. And when you finish, I'll put the answers on the screen so you can check. Here you should have gotten 47 pi over 30. And on number 4, you should have got negative 28 pi over 45. So now if I want to convert from degrees to radians, I want to multiply by 180 over pi. So I knew my pi's were going to cancel out. So 6 goes into 180 30 times, so 5 times 30 is 150 degrees. I'm going to multiply by 180 over pi, so my pi's cancel out. So 3 goes into 180 60 times, so 2 times 60 is 120 degrees. Okay. How do I remember that pi is on the bottom when I'm converting to degrees? Is because you want to be able to cancel out your pi's. So pi's cancel out. 6 goes into 180 30 times, so this would be 210 degrees. So go ahead and you try the last one. If you try the last one, you should end up with 135 degrees. So that's how you can convert between the two. So now let's go ahead and let's talk about arc length. The formula for arc length is S equals R times theta. R is the radius. Theta is the angle. And in order to use arc length, theta must be in radians. In order to use this formula, theta must be in radians. Okay? So here, to find the arc length of a circle with a radius of 4 at pi over 8 radians, I'm going to do S equals 4 times pi over 8. So my arc length, if I would use the calculator, pi would be pi over 2, which is equivalent to 1.571. So the arc length of the radius of 4 at pi over 8, the length of that arc is 1.571. If you look at the second one, notice that theta is not in radians. So I have to first do 15 times pi over 180. So that's going to end up being pi over 12. So now I can do S equals 7 times pi over 12, which is 7 pi over 12, which if I use my calculator is equivalent to 1.833 units. And over here, I would also have to include units. So if I want to calculate the length of an arc, remember the length of an arc, here's my radius, that's this right here. How long, if I were to flatten that out, how long would that be? So now, I just totally went to a different screen. Let's talk about area of a sector. Area of a sector has a formula. It's A equals 1/2 R squared theta. And again, theta must be in radians. So if I do the first one with you, I'm going to do A equals 1/2, my radius is 4 squared times pi over 8. So that's 16. Half of 16 is 8. 8 times pi over 8 is just pi, which is approximately 3.14 units squared. So go ahead and try that next one, and you should get 6.41 units squared. But make sure you know how to do that. Okay? So now, let's look at this scenario. It says, let theta be an angle in standard position, and let xy be a point on the terminal side of theta that intersects the circle x squared plus y squared equals r squared. So that's just the generic standard formula for a circle, equation of a circle, where it's centered at the origin, which it is. So if I were to have a point, let's say over here, x, y, and that's where my angle is, right? That's my initial side. That's how I get my angle. If I drop that down right here, to get to this point, I had to go over x, up y, right? And then what's this on a circle called? What's called the radius. So notice I can compare sine, cosine, tangent, cosecant, secant, and tangent to it. So remember, when sine, cosine, and tangent, we think of SOHCAHTOA. So sine is opposite, so my theta is here. So opposite y over my radius, which is r, because that's my hypotenuse. Cosine is adjacent x over my hypotenuse, which is r. Tangent is opposite, which is y, over adjacent, which is x. So now if I flip all of these, cosecant is the reciprocal, so r over y. Cosine is r over x. And this is supposed to be cotangent, it's a typo. Cotangent is x over y. Okay? Now with this, tangent and cotangent have to have some restrictions. X is not allowed to equal 0, and y is not allowed to equal 0. Okay? Your radii are always positive, so I don't have to worry about the restrictions on cosine or sine, because your radius, you have to have a value. But here, x can't equal 0, and y can't equal 0. It doesn't make sense to have a radius of 0. So if we look at this first example, it says if 2, 5 lies on the terminal side of angle theta. All right, so 2, 5 is like over here somewhere, right? So always goes to the origin, always drops down. Here's theta. So how do I get to this point? I go over 2, up 5. So now I want to do the Pythagorean theorem to find my hypotenuse, because this is my right angle. So 2 squared plus 5 squared equals x squared. So 4 plus 25 is 29 equals x squared, square root. So that's the square root of 29. So now it wants to find the 6 trig functions. So sine, cosine, and tangent. So sine is opposite 5 over hypotenuse, rad 29, which I can't have it like that, so I have to rationalize the denominator. Cosine is 2 over rad 29. I have to rationalize the denominator. And tangent is opposite over hypotenuse, opposite over adjacent, so 5 over 2. So now if I want to do cosecant, which is the reciprocal of sine, that's just rad 29 over 5. And I write this so my brain can remember where it is. I don't have to do extra math. Secant is rad 29 over 2 because it's the reciprocal of cosine. And cotangent is 2 over 5. Okay? So just like we've been doing before. So now, let's go ahead and let's look at example 2. I want you to try example 2 on your own. And when you finish, you can pause the video and I'll go over it. If you don't need to go over it, you can just fast forward to the answers. I'm fine with that too. So -3, -5, that's going to be down here. It always gets theta to the origin, and it always drops a perpendicular down to your x-axis. So I went to the left -3, and I went down 5 is how I got to that point. So now I'm going to have to do -3 squared plus -5 squared equals x squared. So that's 9 plus 25, which is 34. So x is the square root of 34. So sine, I cannot write tonight, let's try it again. Sine of theta is opposite, so -5 over rad 34, but I have to rationalize it. -5 rad 34 over 34. Cosine is -3 over rad 34. So -3 rad 34 over 34. Tangent is opposite, -5 over adjacent -3. So it just ends up being 5 over 3. So now cosecant is the reciprocal of sine. So rad 34 over -5. I'm going to put the negative on the top. Secant is the reciprocal of cosine, so it's going to be negative rad 34 over 3. And cotangent is the reciprocal of tangent, so that's 3 over 5. Okay? So now go ahead and pause this video, and I want you to try that last example, example 3. So I'm going to go over it. If you don't need to go over it, you can fast forward to the end to see your answers. So negative 6, 0 is right there. So that means my turn goes like this. That's how I get to that angle. So I don't have it. Notice I don't have a triangle, but notice my x value is negative 6. My y value is 0. And what about if I make a circle, because that's what all of this does, is it's going to make a perfect circle, What would the radius be? Well, the radius would be 6. Remember, your radius is cancelled. Radii has to be positive. So now I can take that concept up on the top of this page where I'm talking about sine, cosine, and tangent in relation to y, x, and your radius. So sine is equivalent on your paper to y over r. So 0 over 6. So that's just 0. Cosine is x over your radius. So negative 6 over 6. That's just negative 1. Tangent is y over x. Y is 0. X is negative 6. That equals 0. So cosecant, I'm just going to do the reciprocal. 6 over 0. Well, that doesn't work, so that's undefined. Secant is 6 over negative 6. That's negative 1 again. And tangent is negative 6 over 0, which again would be undefined. So these are perfect examples of sometimes when your picture can't make a triangle, like example 1 or example 2 did, think about it as a circle, because that's where we're going, is that all of this relates to a circle. So the last thing we want to talk about is what a reference angle is. A reference angle is the quickest way to the x-axis. It is the quickest way in degrees to get to the x-axis. So on my x-axis, I either have 0 degrees or I have 180 degrees, which is equivalent to pi. So I want to know what is the quickest way. So 135 degrees is here, right? I want to know, okay, what is the distance to get here? If it'll let me. Let's see. Maybe it's not going to work today. What's that distance? Well, how I'd get that is I just do 180 minus 135. 180 minus 135 is 45. So the reference angle to 135 degrees is 45. So now if I do 120, 120 is here. This is the distance, the reference angle, the quickest way to get to the x-axis. So I would do 180 minus 120. Well, that's a 60-degree difference. 187, that's here. So I want to know what this is, because again, I want to know the quickest way to get to the x-axis. So how many degrees is between that x-axis? Well, it's 7, because 187 minus 180 is 7 degrees. And your reference angles are always positive. It's just telling me the distance. Okay? To get from 300 degrees, so 300 degrees is here. So how do I get this? Well, it's 360. This is 360 if I go full circle. So 360 minus 300 is 60 degrees. So what about 379? Well, 379 degrees is a little bit past. So I would just 179 minus 360, that's 19 degrees. So now, if I did this with radians, 4 pi over 3, that's a little past 1 pi, because that's 1 and some change. So I would just do 4 pi over 3 minus pi. So if I were to find a common denominator, that's 3 pi over 3, so that's pi over 3. 6 pi over 11, 11 goes, that's a tiny decimal, so that's 6 pi over 11. So 6 over 11, is that more than a half? It's a little less than a half. Just kidding, I can't do math today. It's a little more than a half. So if it's a little more than a half here, so I want to find its reference angle. So I would just do pi minus 6 pi over 11. So that's 11 pi over 11. So that's going to end up being 5 pi over 11. So you can also remember it, if the angle is less than 180, oftentimes you're going to do 180 minus that. If the angle is more than 180, you're going to just keep subtracting 180. So you can just do that number minus 180, minus 180, minus 180 until you get there. Or you can think about it in these cases when it's over that. So because 180 is pi, if this number is greater than pi, which 14 over 5 that would be, I'm going to just do 14 pi over 5 minus pi until I get to a small number. So your angle always has to be really small. It's always less than 90 degrees. So that would be 5 pi over 5. So that's 9 pi over 5, which is still too much. So I'm going to subtract another pi. So another 5 pi over 5. So that's going to be 4 pi over 5, which is less than half of pi. Well, it's a good thing I still can't do math because I have to subtract another pi. So that's going to be negative pi over 5. So it ends up the distance is always positive. So if it's negative, I just make it positive. So that's one way you can do it. Or if you want me to be honest, an even easier way. 5 goes into 14 almost 3 times. 1. So that's 1, 2. Let's try it again. 1, 2, almost 3 times. So I'm just going to do 3 pi minus 14 pi over 5. And that's 15 pi over 5. So that's pi over 5. So go ahead and pause this video and you do 9 and 10 on your own, and then you can check it on the answer key.